Okay, hello Keen. Let's go through it. So, linear speed is the formula for linear speed is s over t, where s is arc length over time. So like imagine a circle, and then it moves this much over like 10 seconds, right? So it'll move, and then when you like make it a straight line, it'll move this amount of distance in t time, right? So this is the distance s, and then over t time. But also another formula is rate times w, where omega is angular velocity, angular speed, if you have angular speed in the first place. So it always depends on the type of problem you're doing. So there's also two formulas for angular speed. Angular speed has a formula derived from this, where it's v over r, where v is linear and r is radius. But there's also another formula where it goes theta over time. And then keep in mind that these type of formulas often go rate over time, where the rate in this case is theta, so it moves like, let's say 2 pi radians, so that's 360. It moves 360 over t seconds, or so like we can say like 10 seconds, right? It moves 2 radians in 10 seconds, right? So that's rate over time, theta over time, right? And then so we have our two we have our two formulas right here, and we have our other two formulas right here. And let's start with the problem. So static shows like a problem. Let's see. I think you get these. I want to find a hard one. Okay, let's do one of the homework problems. Let me grab my book real quick, and then I'll show you the homework problem. Okay, let's see. I like this homework problem a lot because it was actually kind of hard. It was number, yes, perfect. So there's two pulleys. Bang, bang, bang. I need to draw that better. Okay, pulley, and then this is a belt, right? So basically, what a pulley does, it spins, so it converts angular speed into vertical speed, which is represented in the belt. And the belt has the same vertical speed for, no, same linear speed between this and this, right? But the angular speeds between both circles are different. So what we are asked to do is to find the angular speed of the bigger boy right here, right? Right, guys, right. So we are given the radius of this, which is 2 inches, and we're also given the radius of this, which is 8 inches, right? And then we're also given the RPM of this one, right? The RPM is 3 revolutions over minutes, right? And then remember in the formula up above, to find to find vertical velocity, we have the radius, so we can use omega, right? And we have omega right here. So what we can do is convert is multiply this, so 3 rev over minutes. Make sure to keep all your units, or you'll like freak it up. Times 2 inches, which will equal 6 rev inches over minutes. Wait, that doesn't make sense. Oh, I remember, because you're supposed to keep in radians. I forgot. Okay, so first we want to get revolutions into radians. 1 revolution is 360. So times, you want to cancel out revolutions, right? So rev will always be on the bottom, and 1 revolution is 360 degrees. No, we want in radians, so it's 2 pi, right? Multiply that, well, you get 6 pi min. You get 6 pi every minute, right? Because these two cancel out. And now you have angular velocity in radians, and now you can plug it into the formula to find linear velocity, because as you remember, linear velocity between the belt is always the same. So we can go, we have angular velocity, and we have the radius, which is 2 inches, which is equals vertical velocity, which turns out to be 8 pi per minute. And this time it's vertical, so it moves like this instead of moving like this in from the angular velocity. Now that you have a linear velocity of this belt, we want to find angular velocity of this circle, right? So we can deconstruct the formula where it goes v equals rw, right? We can isolate w, v over r, right? We have v, we have r, so we can find w now. So our new v is 8 pi per minute divided by our new radius is 8 inches, I think. Yeah, 8 inches, which equals omega, which is our angular velocity. We can go 8 pi per minute, which is multiplied by 1 over 8 inches equals w. W equals, you cancel this out, so pi per minute. Wait, did I mess up? Oh, this is actually is 12. Whoops. And then this is 12 divided. No, you can't cancel that. Divide by 12. No, it's not that. W equals 12 pi over minutes. Right? Right. 12 pi over minutes, and then this 8 minutes, and then this simplifies into this simplifies into 3 over 2 minutes. 3 pi. This also simplifies into 1.5 pi over minute. And then now we need to convert this from radians back into revolutions. So we're gonna go 1.5. This is equal to the W, right? And we don't know how much a radian is, so we need to get it back in. 1.5 pi times since this is in radians, just imagine rad. And then we want to get radians, so 2 pi over 1 revolution. Because 1 revolution is 360, 360 is 2 pi. And then 1.5 divided by 2 pi, pi's cancel out. That equals 0.75 minutes per, oh wait, whoops, RPPM. Okay, tell me what you think.